Here we're going to look at equations that are quadratic in form. They are not quadratic equations, but they look like quadratic equations and quite frequently work like quadratic equations, so we're going to solve them like quadratic equations. So what is an equation that is quadratic in form? It is quadratic in form if it's one that can be expressed as a quadratic equation using an appropriate substitution. Okay, so for example, let's take a look at x to the fourth minus 5x squared plus 6 equals 0. This is not a quadratic because it's degree 4. Quadratics are degree 2. But it looks like one. So I'm going to look at what should be my linear term, x squared, and I'm going to say, what if I let that be u? Then what would u squared be? He would be that u, which is x squared, squared, which is x to the fourth power, which is what is in the place of my quadratic. So I'm going to put u squared in the place of x to the fourth. I'm going to put u in the place of x squared. And I have a quadratic equation that results, one that I'm fairly good at solving by now. So I need factors of 6 that add together because they're both negative. They're going to add together to give me 5. That's 3 and 2. But like we said, they're both negative. So u minus 3, u minus 2. Now I have two guys multiplied together to give me 0. So one of those two guys, either u minus 3 is 0, or the other one, u minus 2, must be 0. So I add 3 to both sides and find that u must be 3. I add 2 to both sides to find u must be 2. Do not let that be your answer, though, because look back to the initial equation. There was no such thing as a u. We made that up and substituted it in. So now I'll go back and resubstitute. I know that u is x squared. So I put my x squared back in. And I've got two simple chunking equations. I'm going to take positive and negative square root of both sides. And I end up with 4 possible answers to a 4th degree polynomial. Negative square root of 3, let me get that out of there. Negative square root of 3. Negative square root of 2. Positive square root of 2. And positive square root of 3. So what looked really hard and impossible initially became a simple quadratic, and then when I substituted back in, it was another quadratic. Let's take a look at one more example before I let you go today. This example gives students anxiety all the time, but it's really not as bad as it looks if you take it apart. Number one, it looks like a quadratic equation. I got the second power, the first power. It's just got these fractions with it. So what I'm going to do is I'm going to look to my linear term. I'm going to say, what if I let that be u? X to the 1/3 power. Then I figure out what would u squared be. It would be x to the 1/3 power squared. And when you raise a power to a power, you multiply the powers. 1/3 times 2 is 2/3, and lo and behold, that is what's in the place of my quadratic term. So that is going to work. So I'm going to put u squared in the place of x to the 2/3. I'm going to put u in the place of x to the 1/3. And then what I have as a result is a quadratic equation. So now I'm going to factor. 5 times 2 is 10. Factors of 10, both positive, that add together give me 11, are 10 and 1. Now here's where some people have a little difficulty learning to do it mentally. I know I need a 10. I know I need a 1, but I don't have a 10. I've got 5. Okay, which is going to make that big U. But I can make 5 times 2 to get the 10. So I just make sure the 2 is over here, where when I multiply it will be 10. And everybody up there is positive. And don't forget your 1. Double check it by doing a quick FOIL if you need to. Outer is 10, inner is 1, that makes 11, and the last is positive 2. It checks. So I have factored. I've got 2 factors multiplied together to give me 0. So one of the 2 factors must be 0. Either 5u plus 1 is 0, or u plus 2 is 0. Subtract 2 from both sides, u is negative 2. Subtract 1 from both sides, 5u is negative 1. Divide both sides by 5, u is negative 1/5. My problem is that u was not a part of my problem. But that's okay. I'm going to go back and substitute x to the 1/3 for u. So x to the 1/3 may be negative 1/5. And x to the 1/3 may also be negative 2. How did I solve these problems? Once I got the rational exponent isolated, I raised to the reciprocal power. But what I did to the left, I had to do to the right. So I'm going to, on both equations, raise to the reciprocal power, which in this case is just 3. So, when you raise a power to a power, you multiply the powers. 1/3 times 3 is 1, leaving x to the first power equals negative 1/5 cubed. That's 3 negatives. 1 cubed is 1. 5 cubed is 125. And on the right, negative 2 cubed. 3 negatives is negative. 2 cubed is 8. So I have 2 possible answers, negative 8. And negative 1/25. So even though these problems look really bad, if I'll use substitution, they turn out not quite as bad as they looked.